Now we have found our mirror equation. 1 upon V plus 1 upon U is equal to 1 by F. So this is our mirror equation. Why this mirror equation is very important? Because if we have some mirror, then we find the what is the focal length of the mirror. How can we find? We put some object at some distance u, and just by measuring its image distance we can find the focal length of the mirror. So first time we have to find what is the focal length of the mirror. Once focal length is found for a mirror, then it is constant. It is constant. It will not change. What changes? The distance of the object and distance of the image. So first of all we have to do the experiment to find the focal length. But once this focal length is found, then what we have to do? Then we can easily tell if the distance of object is u, we can easily tell what would be the distance of the image. In this way it is very useful in real life. First time we have to measure this focal length, but after that just by telling the object distance we can tell where the image will form. So this is the usefulness of this mirror equation. But there is one more important quantity. Let us see what is that quantity. The size of image. The size of image relative to the size of object is another important quantity. What is the meaning of this? The meaning of this is that whether the image is of the same size as object, whether the image is smaller or image is larger. So here, as we can see in this figure, this was our object AB, and here we got our image. This was B dash A dash. In this case our image was smaller, but in some cases image would be larger, image could be of the same size. So what is that quantity that define the image size? So we defined a quantity, we call it linear magnification. We call it linear magnification. And what is linear magnification? Ratio of the height of image to the height of the object. Suppose the height of the object is h and height of the image is h dash. Then the ratio of h dash upon h, not h upon h dash, but h dash upon h is called linear magnification. So this ratio of the image height to the object height is called magnification. H dash upon h is called magnification, and this is linear magnification. Now sign convention, h and h dash will be taken positive and negative according to the sign convention. So we know this h is on the positive side, so this is plus h. This h dash is on the negative side, so this is minus h dash. This is in our case, but in some other cases this might be opposite, that h is negative, h dash is positive, or both are positive, both are negative. That depends from case to case. But in this case h is positive, h dash is negative. Now let us come to our figure. So this is our figure. In this figure we have this equation. This is also, we have seen this equation previously. B dash A dash upon BA is equal to B dash P upon BP. Also let us see once again from this figure. So this B dash A dash upon BA, this is the quantity we are interested, because this B dash A dash is the height of the image divided by height of the object. So this is we are interested. So let us find out how we can see. So in triangles APB, A dash P and ABP, these two triangles. So first triangle is A dash B dash P. So this is our first triangle. And what is second triangle? ABP. This is our second triangle. So we have already learned that if this angle is phi, this angle must also be phi, because angle of these are angle of incidence and angle of reflection. From the law of reflection, these two angles must be equal. So in this first triangle, this AB, let us write tan phi. Tan phi is nothing but AB upon this total distance BP. In second triangle, this is B dash A dash. divided by b dash p. Now let us write in different way. So this b dash a dash upon ab this must be equal to b dash p upon bp. So this is our equation. This we have already found in the when we are solving for the mirror equation, but we here once again we have found the same equation by applying the property of the similar triangles. So tan phi is equal to tan phi. So this is our equation. Let us put the values. So what is the value of this b dash a dash? It is minus h. It is minus h. What is ab? Ab is h. Now this, what is this bp? B dash p? This is the distance of image from the pole. So this was minus v, because all the distances are on the negative side on x axis. So this is minus v. What is bp? Distance of the object from pole p. It was u but minus u. So with the sign convention we got this. So this negative and negative cancel out. So what we get? Minus h dash upon h is equal to v upon u. This is our equation that we have got. Now what is the, how the magnification is defined? Magnification is nothing but ratio of h dash to h. So ratio of h dash to h, so minus goes this side. So previously minus was cancelled out, so this minus goes this side. So magnification is nothing but h dash upon h, and this is minus v by u. So what we can see? We can see that h dash upon h depends on the distance of image and image of the object. Distance of the image and distance of the object that we know. And what is the minus sign? Minus sign means the object will be inverted. As we can see in this figure, the object will be inverted. So we have derived here the mirror equation 9.7 that we have seen, and the magnification formula. This is the magnification formula, and mirror equation is 1 upon f is equal to 1 upon u plus 1 upon v. So these are two important quantities, magnification and mirror equation. And the magnification formula this. For the case of real, so we have seen in case of this, image was real, image was inverted formed by a concave mirror. So image was real but inverted. So we have taken upwards but the image was coming downwards, that means it is inverted. With proper use of sign convention, these are in fact valid for all the cases. So if we put the sign convention properly, these formula, this mirror equation and this magnification formula is valid for all the cases of reflection by spherical mirrors. So this is valid for both type of mirrors, concave mirror or convex mirror. So it does not depend on the mirror type. It is valid for all of them, whether the image is formed real or virtual. So whether the image is virtual or real, if we apply the proper sign convention, these formulae are valid for concave and convex mirrors. There is no problem with these formulae. Figure 9.6 shows the ray diagram for the virtual images formed by concave and convex mirror. So there are some cases where the images formed by the mirrors could be virtual. You verify these equation 9.7 and 9.9 are valid for these cases as well. So this is an exercise for you to verify that these equations are valid for these cases as well. So now we have learned what is the mirror equation and what is the magnification formula. Magnification is negative, means image is inverted, as we have seen in case of this concave mirror. So please try to solve for these two cases. This is the same case but for convex mirror. This is the case for concave mirror, but now image is, or the object is kept between this focus point and this pole. Previously object was far away, but now the object has kept at a point between focus and pole. So the situation is changed, but the formula will remain same. So please solve these things. Let us see this example 9.1. Suppose that the lower half of the convex mirror's reflecting surface in figure 9.5 is covered with an opaque non-reflecting material. So what we do? We cover the lower half with the some opaque material. What will be the effect of have an image of an object placed in front of the mirror? Suppose if we have this upper part is reflecting, but if this lower part becomes non-reflecting, then what would be happen to the image? That we have to tell. You may think that the image will now show only half of the object, but taking the laws of reflection to be true for all points of the remaining part of the mirror, the image will be that of the whole object. However, as the area of the reflecting surface has been reduced, the intensity of the image will be low. So first of all, we think that since half of the mirror is somehow coated with a material that is opaque, so we think that image will be half formed, but image will be completely formed. Only the intensity of light, the sharpness of the image will be reduced, not the image size. Image size will remain same, only the intensity of the image will be changed.